A sign with a mass of 5.6 kilograms is suspended at rest by 2 wires as shown below. Find the tension in each wire. Okay, little quick tip. If a sign is hung by 60 degrees on both sides by the same type of wire, the tension in each of these wires will be the same. So instead of naming this FT1 and FT2 like I would if there were 2 wires, I'm going to name these both FT. Please note that the hypotenuse of these would be FT, and that's what we're looking for. We're looking for the hypotenuse of each of these. So I have my free body diagram, FT and FT, and that's what I'm looking for. I don't know either one of these. Finding either would be suffice, and it is the same. And then I have FG pointing down. So it is a common error that students would put here an FN going back up from FG, but there's no FN if there is no surface below this. So we have the sum of the forces in, oh wait, my green arrows are in both the X and the Y. So my first step is to draw a free body diagram, but a subset of that is if there are triangles, I'm going to break them up into their components. So I'm going to go ahead and draw my components here. I have the X component, FTX, and I have another FTX going the other direction, FTX. And then I have FTY and FTY. Now, if I take a look, I can see that the blue arrows are going to cancel out. They have the same FT, they have the same hypotenuse, they're going to have the same X component, and they will cancel. So even if I did this, I would have the sum of the forces in the X direction. I have the forces going to the right, minus the forces going to the left, and the sign is at rest, so the sum of the forces will equal 0, and we would just get these would cancel. So there are no sum of the forces in the X direction. In the Y direction, however, the two FTYs here will add. They will not cancel out. So what I have here is sum of the forces in the Y. I have an FTY and an FTY minus an FG. The force is going up minus the force is going down. And because the sign is at rest, it's at rest in both directions. The sum of the forces is, again, 0. So if I take this here, I'm going to just add like terms. I have two FTYs, so I'm going to end up with the 2 FTY minus FG is equal to 0. And I can go ahead and solve for FTY. So FTY is equal to FG divided by 2. MG divided by 2. M is 5.6 multiplied by 9.81 and divided by 2. So I have 27.468. And that will be in newtons. Now, I could round this to 3 sig figs, but I'm not going to because it is not my final answer. However, what I do have is I have the Y direction for either or of these triangles. I could put it on either side. It doesn't matter, but I'm going to take one of these and blow it up just for effect. So I'm going to say FT. That's what we're looking for. This is our question. And then I have the Y component, which should be pointing upwards. This is 27.468 newtons. And I have an angle here of 60 degrees. Now, I don't know the X component. I don't know FTX. But what's good about this is I don't need to know FTX. I have the opposite side. And I'm looking for the hypotenuse. And I have the angle. So I'm going to use the sine function. And I'm just going to solve for h. The opposite side is 27.468 newtons divided by the sine of 60 degrees. Going to take this answer, divided by sine 60. And fun fact, the sine of, I don't want to say that fun fact. Okay. (31.7 newtons). And that's going to be the tension in each wire. So Ft is equal to 31.7 newtons. All right.